Okay, to start with, let's go over some homework questions from our first section from last week, which was section 3.3. Section 3.3, homework problems on page 217. Which ones should we start with from 3.3?
40.
Number 40. Two-fifths x to the fourth minus 23x squared plus 1/15 x to the fourth minus 5x squared minus 5. Our directions for these problems ask us to simplify the expression by combining like terms. So I'm looking for these and saying, well, which ones have the same x's? Which ones seem to be related? This one has an x to the fourth, right? And there's one more that has an x to the fourth right here. So these two have the same variable part. That makes them like terms, and they can be added together. So if I were to add 2/5 x to the fourth plus 1/15 x to the fourth, this is a little hard because of the fractions, right? Think of it like this. If I have 2 apples plus 3 apples equals 5 apples, right? But the apples don't change. Even though I add this plus this, I have 2 of those things plus 3 of those things, and now I have a total of 5 of those things, right? So the same thing happens with like terms. I have this much, 2/5 of a pie, part of a pie, and I add to that another tiny little sliver of a pie, and when I get done, what I end up doing is adding the 2/5 to the 1/15, and then still just tacking on x to the fourth. The variable part doesn't change. Does that make sense? So now I just have to think to myself, what is 2/5 plus 1/15? I can't add fractions unless I have the same denominator. So I'm going to change the 2/5 to being something over 15. I get this by saying times 5. And then I take this times 5 and get 10. So this is equal to 10/15.
Would it be 3?
Yeah, it would be 3.
5
times 3, not times 5. Oh, great, that's recorded. Times 3 equals 6, times 3 equals 15. Better. So that would be 6/15 plus 1/15. Now that's a total of 7/15. So that's the coefficient on x to the fourth. Plus, so these are done. When I identify like terms, if I'm doing a problem like this, I very often circle or underline the ones that match, and then once I've added them together, I'll just draw a little line through them so that I know I can forget about those and I don't get distracted or worried about them. So I don't know if you want to do that, but a lot of times I'll cross those off, and then I think, okay, what's the next thing that matches? Here I have an x squared, and this term also has an x squared. So if I was going to take a negative 23 of those things, and then add another negative 5 of those things, together negative 23 and negative 25 would be negative 28 of those things, which is x squared. So adding the coefficients and tacking on the variable part. So now I could cross off these two things, and the only thing I haven't touched yet is this 5, or negative 5. Does negative 5 have any family here? No, right? The cheese stands alone. So we just put him on the end. He doesn't have anything else to add with him. That's where they get that answer. Notice this time I wrote plus a negative 28, and this time I just wrote subtract 5. It means the same thing to write plus a negative as it does subtract. I had already written down my fraction and then a plus sign instead of a subtract sign, so I just made that a negative 28. But it's the same whether you say minus 28 or plus a negative 28. It's the same value, and it's not one's right and one's wrong. One's not even more correct. It's either way you write it, totally fine. Completely even. What else from section 3.3? Okay, section 3-4.
10.
Number 10 on section 3-4. Oh yes, this is that decimals question. Page 225, number 10. Now the problem in the textbook actually starts out with parentheses here and here. But we remember from the very first, one of the first things we did in the early chapters was we talked about the associative property and who associates with who on the playground, and we said that really addition is associative and it doesn't matter what we add together, who is in what group. So these parentheses, while they exist in the original problem, don't really have any power. If this was subtraction, I would say I have to make sure everything is changed sign, minus all of that changes all of those to a different sign. But the way this problem is written with addition between the parentheses, that the parentheses don't even have any real meaning. So my job now is to simply go through and find all the things that match. So I'm going to erase these parentheses. Not really necessary. Now let's just go through, and what's the first thing you see that matches?
9.6 y cubed and 1.1 y cubed.
This one and this one. Yeah, they both have a y cubed, right? Same variable part. They look like maybe they're in the same family. So we can add these two things together. So what is 9.6 plus 1.1? 10.7. Or you can do that on your calculator. Now again, I have 9.6 of those things and 1.1 of those things. When I add them together, I have the same variable. Sometimes people say, shouldn't it become y to the 6th? Shouldn't something happen with that y if I'm adding them together? And that's when I go back to imagine it's 2 apples plus 3 apples. I now have 5, but they're still apples. They don't change anything else. Next thing, I'm going to go ahead and cross those out so you can see what I mean. Hopefully that doesn't make it too messy. Next thing that's the same is these two y square. Oh, was one squared and the other one not? This one is squared, right? Does he have anything else like him? No other squares, right? I thought I wrote this down wrong at first. I thought this was supposed to be squared, but it's not. So this guy is all alone. There's no other y squared. So I'm just going to copy him down here. Well, that's kind of boring. And then I'm done with him. So I'm going to cross him off. Next I'm going to come over here and say minus 8.8 y to the first power. No other y terms, right? This does not have a y. This does not have a y. So he does not have anyone to add to him. I'm just going to write him here as well. And then I have this guy, minus 8.6, and plus 11.6. This one's negative, this one's positive, right? Well, now I want to think to myself, what is positive 11.6 and negative 8.86 added together? This one's positive, this one's negative. When I add them together, I'm actually finding the difference between those, so I'm going to subtract this. 11 minus 8 is 3.0. The 11 is bigger, and it's positive, so my answer is positive.
All that work on there, I don't know if I got it. I got like 22.2 y to the third plus 3. But I have all that in the book. I don't know.
You know what I bet if you add these three things together,
I think I did that.
I bet you get 22.
Okay.
Yeah, because 10 plus 2, that would be 12. And if I add this is almost 9. I mean, I bet if you add that all together, you get 22. Probably. But keep in mind that even though they all have y, I don't get to actually add them together because it's y to a different power, which makes them like, second cousins. But I don't get to add them together. They're not the same. They're not like terms. Another one from 3.4. Number 30. This is on page 226. Oh, I can tell what we don't like about this problem, right? Too many fractions. All of these are fractions that I'm adding and subtracting. And so if I'm going to do that, I have to have like denominators. They have to have the same denominator to add fractions together. I'd kind of like to eliminate the parentheses, like I did before, just erase them. But before I do that, I have to pay special attention to this, right? Because when I subtract, this subtraction sign is going to influence everything in this parentheses, right? Think about this. If you have your paycheck, pretend you made $100 this week, and then from that paycheck, there's a big minus sign, right? Because the federal government gets a little bit, the state government gets a little bit, Medicare gets a little bit, right? All those things come out of your paycheck. So your $100 minus parentheses, federal tax, state tax, Medicare, whatever comes out. I don't know all this. When I subtract all of that from my paycheck, this stuff in the parentheses I could add together, right? Federal tax plus state tax plus blah, 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 and say, okay, it's my $100 minus cha-ching. What I mean is this. I made $100, and I'm going to take away three things. Federal, state, and Medicare. Let's say this is $5, $5, and $2. I add those together, right? And then I take my 100 minus $12. Does that make sense? But what if what's in the parentheses is not three things that I know? What if what's in the parentheses is X, Y, Z, right? Not number, number, number that I can actually add together. If that's the case, then to simplify, I want to do this. Plus, and then I change the sign of everything in here. Minus 5, minus 5, minus 2. So I take 100 and I subtract 5, and then subtract 5, and then subtract 2, and I get the same answer. But when you subtract three things, you're subtracting all of those things. And the common mistake is to change this to addition and make this subtraction and not anything else, right? The common mistake is to say, I'm going to take those parentheses off of there and make this a negative 4/21, but then leave those alone. And that's not okay. A lot of people say it helps them if they think about this as being a negative 1, like adding a negative 1 on here, times the parentheses. So instead of just subtraction between there, they visualize it as a negative 1, and then they distribute the negative 1. And they take negative 1 times this, and times this. So that when they rewrite it, without the parentheses, they distributed the subtraction. It's a negative 4/21 x squared minus 1/21 x. And then this minus a minus is really plus 2/3. But before you take the parentheses off, you have to change, if you're subtracting, you have to change the sign of everything in the second parentheses. If you're subtracting, you have to change the sign on everything in the second parentheses. Because I'm not just subtracting one thing, I'm subtracting all of it. So it's minus this, and then minus this, and then minus a minus, or minus a negative, to make it a plus a positive. All right, now that I have this rewritten, that was a little lengthy, I want to see what's the same. This guy has an x squared. This guy has an x squared. Yes? So 1/3 plus negative 4/21. I'm going to change the 1/3 to be something over 21. 3 times what is 21? 7. So 1 times 7 is 7. And then I have a negative 4 over 21. That equals a 3 over 21. 7 minus 4 is 3. And 3 21st will reduce to 1/7. Because 3 goes into itself 1 time and 3 goes into 27 7 times. So that's going to be the coefficient on x squared. When I add this to this, I add the coefficients and then tack on the x squared. Next is a negative 2/7 and a negative 21. Those both have an x, so they're like terms. When I go to add those two things together, I have to add the two fractions. Negative 2/7 plus negative 1 over 21. The common denominator, of course, is 21. So I'm going to multiply this times 3 and this times 3, so that gives me a negative 6 over 21. It's a negative 1 over 21. That's negative 7 over 21. Negative 6 plus negative 1 is negative 7. That reduces to negative 1/3. And then I have this last little fraction, plus 2/3. So I'm linking the colors here. Adding these coefficients is done in the red over here, and adding these coefficients is done in green on the right.